All right, good day. Today's discussion will be covering a general description of the emergency Autoland system and its workings. As we go through this discussion, keep in mind that Garmin has been working for almost a decade in this system. My name is Alejandro Prem. I'm the Training and Knowledge Manager for Dyer Aircraft Inc. My contact information is right there below. And we're going to talk about the characteristics of the emergency Autoland system equipped in the TBM series aircraft. Make a little bit of memory. Back in 1999, October, we had a tragic story developed in a charter Learjet 35. This aircraft was scheduled to fly from Orlando, Florida to Dallas, Texas. However, early in the flight, the aircraft, as it was climbing to its assigned altitude, on autopilot, it lost cabin pressurization, and all 6 persons on board were incapacitated due to hypoxia. Well, the aircraft continued to fly and climbing past its assigned altitude. Instead of turning westward towards Dallas, it continued over North Florida. And basically, the aircraft flew for about 1,500 miles until it ran out of fuel over South Dakota, where it crashed into a field after an uncontrolled descent. So this is kind of like a famous accident because there was a famous PGA golfer, Payne Stewart, inside this aircraft. And the subject of our discussion today is to cover an evolution to the already existing safety nets in the TBM, such as emergency descent mode and electronic stability protection. So one thing that we need to keep in mind is that emergency Autoland is for emergencies only. Once the system has been triggered, it assumes that upon engagement, there is not a capable pilot available to safely fly and control and basically land the TBM. The system is designed to perform the functions required for landing. And in the TBM world, it has its own commercial name and is called HomeSafe. So HomeSafe includes hardware and software changes, which will allow the TBM to perform a fully autonomous landing in the case of pilot incapacitation. So the landing is performed on a terrain chosen by the system, which not necessarily might be the planned destination. And also at the same time, air traffic control is warned through automatically generated notifications. So in order for HomeSafe to trigger, it's going to go through the following phases of operation. First, there has to be a HomeSafe initiation. Now, this could be either done manually by pressing a button, or it could be done automatically by the aircraft system as it senses that there is something wrong with the aircraft. This is going to be followed by an airport and runway selection, and also automated communications with air traffic control. Now, the criteria for selecting the airport is going to be based on METAR data, and it's also weighed depending on some of the attributes that have been put by the OEM. The automated ATC messages are going to be handled by your communication system, and also it's going to go through transponder in emergency code. Once the runway and the airport has been selected, there's going to be a flight path routing where the aircraft is going to manage the routing and is going to look into terrain and weather avoidance. Direct descent path calculation is going to be done to the final approach fix. And now the aircraft is going to configure itself in order to land, meaning that the flaps and the gears are going to come down, the landing lights are going to turn on, and the airplane is going to meet the approach rules. It's going to perform a flare, and eventually is going to touch down. So for all this, we're going to be using the autopilot and also the auto throttle. Is going to try to keep the airplane centered in the runway. Once it has touched down, it will apply the brakes automatically. It will keep the airplane centered using steering. And at some point, the engine is also going to shut down by shutting off the fuel. This will conclude the safe landing of the TBM by using HomeSafe. So HomeSafe is equipped in the TBM 940 airplane and lately in the TBM 960. The reason for this is these aircraft are equipped with G3000 avionics. They also use auto throttle. So in the following short film, it's going to explain all of the attributes of HomeSafe and how this is going to be deployed.
Safety has always been Dyar's top priority. This was the motivation for Dyar's outfitting of its Kodiak 100, TBM 910, and TBM 940 aircraft with autonomous safety systems such as angle of attack, underspeed protection, electronic stability and protection, emergency descent mode, and more recently, auto throttle. Today, the TBM 940 is equipped with the HomeSafe system, allowing the airplane to land by itself if the pilot is incapacitated. This video will explain how the system works and how to react step by step. The HomeSafe system can be activated by anyone on board the aircraft with the simple push of a button. The orange HomeSafe button is situated at the top of the cockpit instrument panel, visible from any location within the cabin. Before pressing the HomeSafe button, the first step is to enter the cockpit and check the pilot's condition by asking questions or by gently shaking the pilot's shoulder. If the pilot does not react, the passenger should engage HomeSafe. To activate the system, press and hold the orange button in the cockpit for approximately 2 seconds. The button can be pressed multiple times without any risk of disengagement. In any situation, HomeSafe can be re-engaged by pressing the button again. After pressing the button, the white logo will light up and the button will start flashing. Audible warnings will confirm HomeSafe's activation.
HomeSafe request.
Once the system is activated, the passenger should be seated with their seatbelt fastened. No additional passenger action is required. During the flight, the system will give information guidance to passengers. To follow these audible and visual instructions, the passengers should wear a headset that is plugged in and watch the instrument panel's middle screen. With HomeSafe taking control of the airplane, the flight control wheels, pedals, and power level will move autonomously. The passengers must not interfere with them and should check that the front occupant's feet are clear of the pedals. "15 seconds after activation, information updates will be provided by the 3 large screens and 2 small touchscreens in the cockpit. Each screen is composed of 2 information areas, an overlay on top and bottom of the screen and the main content in the center. Both lateral screens will display details concerning the upcoming maneuvers and the name of the selected landing field. They will also show a standard display in the airplane's position on a map. The middle screen will contain information on the distance, the time, and the fuel remaining before landing. It also will display a series of videos related to the phases of flight, providing information to the passengers until the airplane comes to a complete stop. After each video, the screen will display a map showing the complete flight route. The 2 touch screens will give the airplane identification number and show a microphone illustration, which will be discussed later during this video. Once engaged, HomeSafe will immediately start searching for an adequate destination to land. Taking weather conditions and the surrounding environment into consideration, the airplane will determine the optimal landing field. When selected, the airplane will start maneuvering in order to reach this destination. At the same time, HomeSafe will communicate by radio to notify air traffic control and other aircraft about the airplane's emergency status, as well as the selected landing site and the necessary parameters for the flight's completion in the safest conditions. These communications can be heard by the passengers. Once informed, the air traffic controller will establish the corresponding emergency procedures concerning the aircraft and its occupants. If the passenger wishes to communicate with an air traffic controller, Passengers must use one of the front seat headsets and one of the touch screens on the instrument panel. If no one is seated in the right-hand seat in the cockpit, a passenger should move from the cabin to this seat and put on a front seat headset. If other passengers want to speak with the passenger in the front seat, they can do so by using the intercom function on their own headsets from the cabin. To speak to air traffic control, the passenger should press and hold the microphone button on the touchscreen. The blue frame indicates the microphone's activation. To hear the air traffic control's response, release the pressure on the touchscreen. The audio volume can be adjusted by turning the knob on the touchscreen panel's bottom right corner. Before the aircraft configures itself for landing, a video will explain to passengers what is happening. The flaps and landing gear will deploy, generating sounds related to their deployment. These sounds are perfectly normal, and passengers should not be concerned. A red light and 3 green lights will then appear near the left control wheel. This is normal, and passengers should not be concerned. To prepare for landing, passengers should stow the table and secure all loose objects in the cabin. Luggage should be stowed in the appropriate location, not left in the cabin. Each passenger should make sure that their seatbelt is fastened tightly. After landing, the aircraft will automatically apply the brakes, stop, and shut down the engine. After the complete stop, passengers can unfasten their seatbelts by turning the buckle on the front seatbelts or by pressing on the buckle on seatbelts in the cabin seats. To unlock the door, press and hold the black button located to the left of the handle, then pull and rotate the handle counterclockwise. Before exiting, passengers should quickly analyze the situation. Decisions in preparing to exit the aircraft should not be delayed. Apply first aid when necessary. Finally, passengers should seek or call for help. All information provided in this educational video is included in the HomeSafe instruction card available to passengers aboard the aircraft and will be repeated by the HomeSafe system when activated. If needed, passengers should ask the pilot for more information when entering the aircraft.
So as we see from the video, there is a manual activation mode for HomeSafe based by pressing the button, but we also have automatic activation on HomeSafe. And this is going to refer to emergency descent mode and level mode. Now, HomeSafe is going to activate after a depressurization of the aircraft. What that means is the aircraft is looking at the cabin pressure. If it senses a depressurization above 10,000 feet cabin altitude, and if there is no response from the pilot, autopilot is going to engage. It's going to induce a 90-degree turn towards the left, deviating from the flight plan, and it's going to bring down the airplane to a safe altitude of 15,000 feet at maximum speed. Once the aircraft is leveled at 15,000 feet, it waits for a response from the pilot. If there is no response from the pilot, EDM will now convert into HomeSafe, basically trying to land the airplane on its own. The other way that HomeSafe will be triggered automatically is the level mode. Now, level mode is a function of the autopilot, and think about it as a kind of a panic button for a disoriented pilot. So this is not a normal way to fly. So if we stay on level mode for more than 2 minutes, the airplane thinks that the pilot is incapacitated, and it will trigger HomeSafe to become active. So this will be the initiation of HomeSafe. So there's going to be a call out for HomeSafe that it has been active, and there's going to be a cautionary step. Basically, this cautionary step includes a 15-second wait period where the avionics remain in normal mode with oral message that the HomeSafe has been requested. That is going to be played through all the headsets and the aircraft speakers. And we're also going to have a CAS message that says HomeSafe request. This is going to be generated automatically by the system. So the goal of this cautionary step is to give a chance to the pilot to deactivate the function before it takes control. Once the HomeSafe takes control, the autopilot will engage if it has not been previously engaged, and is going to engage in level mode. Now, the autopilot will initially fly the aircraft in its current mode while initiating the destination airport selection process. And this can happen at any time during the flight. Could be during climb, could be during cruise, could be during a descent. So the cautionary step is important because it's much easier to reconfigure the aircraft if we disconnect HomeSafe during the cautionary step rather than when the full emergency Autoland has kicked in. For example, the pilot does not need to reset the flight plan, the communications or transponders, or not even the barrel settings. Auto throttle will also be engaged if it hasn't been previously engaged, and it's going to adjust the engine power or the thrust in order to achieve the commanded FMS speeds references. So we have a contribution here between the auto throttle and the autopilot working together. So HomeSafe has been requested, it has initiated, and now the system performs an airport and runway selection. This is based on algorithms that live inside the system and is going to determine the most suitable landing runway. So the algorithm, it runs on optimization schemes that consider a number of factors, including approach attributes, for example, runway attributes as far as the length, the width, inclination of that runway, the distance to the destination, the wind, and the fuel remaining. So the system will require a GPS approach with vertical guidance. It does not require controlled airport, but this OEM has set merits to prefer tower airports, and it will demerit Class B anchors due to potential disruption to major traffic. And we all know that we have regional airports around Class B anchors. So the thought being that tower airports are more likely to have emergency services nearby, and the system will use bar VNAV at a minimum. The routing algorithm is going to use the final approach fix from published approach charts that avoid terrain, obstacles, and also significant weather. So when HomeSafe is activated, when HomeSafe has gained control of the aircraft, it generates an emergency situation broadcast by using synthetic voice on air traffic control and declares an emergency on the transponders by setting them to emergency frequency. So the pilot incapacitation message is going to be broadcasted in the last frequency on your COM number 1. Once the system has determined where it's going to land the aircraft, the broadcast will include information on the current position of the aircraft and its destination. So it's going to use both COMs for this. COM number 1, it broadcasts this message once, and in COM number 2, it's going to go to emergency frequency, and it's going to repeat this message every 5 minutes. As the aircraft is getting closer to its destination airport, COM number 1 is going to change to the tower frequency of that airport, and is going to start the automatic message communication with the tower. Now, the message is going to include information on the current position of the aircraft and the destination, also the time estimated to that destination in order for ATC and for the ground to clear the path for this landing aircraft. If the airport has not been found through the database, or maybe we are flying through a path that there is no available airports, the broadcast alert that the aircraft is actually seeking for a destination, and basically the frequency is going to be the same as above. Now, the system has been originally designed to look at a radius of 200 nautical miles for a destination airport. This has been increased to 500 nautical miles in order to reduce the possibility of delaying the destination airport. So at the same time that these communications are happening, all of the occupants are using headsets plugged into the cockpit. So if we have somebody sitting on the co-pilot position, for example, they can talk to the ATC on the frequency that was selected by HomeSafe and by using the push-to-talk interfaces on the GTCs. So the intercom is also open, allowing any headset to listen to the passenger content and also the broadcast of the emergency messages. Also, any potential instructions coming from ATC. Now, for this, we see that the displays, both Garmin display units and also both GTCs, change. And this is what we consider the user interface for the emergency Autoland system. The automatic radio transmissions, they will convey important information to our traffic control. Basically, we have synthetic voice messages to broadcast emergency situation to our traffic control. These are going to be generated by the Garmin integrated avionics units and also by the audio panels. Basically, the notification of the emergency condition, the identification of the aircraft, telling that emergency Autoland is active, the current location of the aircraft, also followed by the destination airport and the runway chosen by the system. Information will also include the estimated time to the destination. The transponder will also change. Transponder tunes to emergency frequency 7700 and also ADS-B emergency priority status with any associated emergency codes. Okay, so the transmission is now repeating. It will repeat on both comms. And now the system is going to follow up the route management. Once an approach and a route have been identified, the HomeSafe system is going to determine the vertical profile, basically either climb or descent in order to avoid terrain. It also is going to manage the route to avoid weather based on storm movement. The idea here is if the weather changes significantly, HomeSafe will also update the route in order to try to avoid severe weather. So the system works on terrain database, and it also uses all of the data link weather sources. It's going to use the VNAV function, a three-dimensional path, and it's going to respect any altitude constraints. AFCS and auto throttle will manage the aircraft speed and also the altitude. So the system uses all of the data link weather sources available to it, but it will not use the weather radar. And these sources can be multiple. We could be talking about XM weather through your GDL69, or it could be ADS-B in FISB through compatible transponders. Could be using Garmin Connect's weather through GSR56, for example. The Garmin Autoland uses GPS approaches which are available on all continents. This includes Antarctica. And the system was designed to function at thousands of airports worldwide without requiring any additional systems of the airports. Basically, it's a self-contained system. What we're seeing here is just an example of how the Garmin display units are going to change in order to facilitate the understanding for a possible non-pilot that is flying inside the aircraft. So we're going to see that the user interface becomes simplified in order to be understandable by non-pilots. The two primary flight displays are modified to show a simplified PFD, and also 40% of that real estate in that PFD are going to show a map with the track up and the auto range function. We're going to have different indications here that could be useful for the passengers as warnings, letting them know in advance that the aircraft might be banking towards one side or the other in order to do some certain maneuvers and for them to prepare for this. Also, it will advise the passengers the time remaining before starting a descent and the estimated time towards its destination. Additional information can be looked into the multifunction display or the center screen, where it shows geographic progress with the north up and the range to cover the whole HomeSafe sequence. In this case, it will also give you information as far as miles remaining, fuel remaining, and the time remaining in flight before accomplishing your touchdown. What is important of this system is that there is no action required from the passengers. However, if we might have a passenger that is sitting on the right-hand seat that might want to communicate with our traffic control, this is also doable. The two Garmin touch controllers with the touchscreen interface, now they become kind of like radios. Basically, we have the passenger push-to-talk function, which is part of the GTC. And in this case, the passenger can communicate with our traffic control if necessary. So the broadcast of the emergency message has been done. we have transponders on emergency mode. The aircraft has selected a destination airport and also a destination runway. And now the aircraft needs to configure itself in order to go ahead and land. So the HomeSafe system is going to manage all of these aircraft systems as needed to put the aircraft in the required landing configuration. We know that the communication of the emergency state of the aircraft has been done already. And in this case, we're going to have specific interfaces that include your automatic flight control system and your auto throttle. It's going to be the movement of your flaps and your landing gear, also your landing lights, in order to be able to accomplish a successful landing. For this case, HomeSafe is going to use the climb, cruise, and descent VNAV functionality in order to slow down the aircraft during the approach, in order to allow for the landing gears and the flaps to deploy at the correct speeds. So the first thing that the system needs to manage is the deployment of the landing gears. So the Garmin system is going to use discrete outputs from the GIAs in order to trigger relays that will allow the aircraft reconfiguration for both landing gears and flaps. For the landing gear management works also with the landing gear lights. Remember that this emergency landing could be at night, and the system wants to cover all possible scenarios to make the aircraft visible. The landing lights and the landing gear deployment, we say that it activates at the same time, and the system uses a common relay with a double pole in order to do this. So basically, the relay overrides the landing gear lever in case of a HomeSafe event. This relay, the location, this is located inside the pressurized part of the aircraft in a safe location. And the logic behind the activation of the landing gear is going to happen as it's explained here below. Basically, the logic is looking that we have the emergency Autoland function active, and it looks at the aircraft. The aircraft has sequenced the final approach fixed waypoint since more than 15 seconds ago, and it's also looking at the aircraft speed that is lower than the maximum landing gear extended speed, in this case, 178 knots. So the whole idea is that HomeSafe is looking for a very, very stable approach in order to bring down the gears. The speed and the altitude is under control, and now it's time to bring the gears down at a safe speed. HomeSafe will only sequence the final approach fixed waypoint when it has determined that the altitude and the speed are under control. We're going to have a video in the MFD that is going to warn the passengers that they will hear noises and that they are normal due to the deployment of the gears and also of the flaps. Now, maybe the airplane is coming down too steep, or it has found a destination airport, and now the airplane has to shoot down to that destination. Maybe it's coming at a higher altitude. Maybe the speed is not controlled. The aircraft will analyze that, and if it's not set up correctly for speed or altitude, it will command a holding pattern. This is going to be visible in the MFD, in the map. It's going to draw down the holding pattern, and once it hits a holding pattern, the gears will not extend while doing the lap. So this gives the airplane enough time to stabilize as far as altitude and speed, and then it's going to lower the landing gears once everything is set. Okay, so the gear has come down, and now it's time to manage the flaps. So we're going to have different relays in order to control all the flight surfaces here. In this case, for your flaps, we have a different relay which is going to command the extension of the flaps commanded by HomeSafe. Now, one thing that we need to keep in mind in this aircraft is that we do have different positions of the flaps, obviously. On the TBM, we have 3 positions of the flap switch. That's flaps up, flaps takeoff, and flaps landing. Basically 0 degrees, 10 degrees, and 34 degrees corresponding to those positions. When HomeSafe commands the flaps to go down, only the landing position is commanded by the emergency Autoland system, basically bringing the flaps from flaps up all the way to flaps landing at the 34-degree position. So the system uses both GIAs, and we're going to have discrete outputs for the flaps extension, and is looking at a similar logic like what we saw for the landing gear extension. In this case, the activation of HomeSafe is looking at the aircraft sequence, the final approach fixed waypoint, in this case, more than 45 seconds ago, and is looking at a different aircraft speed, basically looking at the maximum flaps extended speed of 122 knots. So we have a different time frame here than the landing gears. Remember that we need to allow the landing gears to go down. We need to play a video for the passengers. So there is this 30-second delay after the landing gear deployment. And this is to allow for aircraft stabilization before the flaps are coming down. Okay, so the landing gear is now down. Their flaps are in the landing position, and the airplane is now, almost above the runway. And now it's time for the system to configure the flare. Now, the flare in the Emergency Autoland introduces a new AFCS mode for the flare phase. This is the only new mode introduced for in-flight phase in HomeSafe, excuse me. So this new introduction of the AFCS mode, well, it includes autopilot and auto throttle modes for the flare. Once we touch down, it's also going to affect the centerline tracking and the automatic braking of the aircraft. So the approach modes are those used for regular RMP approaches. It's going to follow published procedures. In this case, the system will use the radar altimeter. So radar altimeter is keeping track of the aircraft altitude and is going to command in the AFCS positions on the nose to be pulled up and also a new position on the auto throttle for throttle to be coming down. The approach speed during HomeSafe is going to be 95 knots, which is a little bit higher than our normal approach speed, but this will make it compatible with any icing conditions. Now, this aircraft, they have automatic ice detection and automatic ice protection. However, in case that there would be a malfunction on the system is prepared to do an approach at a little bit higher speed in order to try to prevent a stall. Okay, so the flare, as we said, this is commanded by your AFCS and your auto throttle. And, just looking at how the system works is looking at aircraft altitude based on radar altimeter. So the aircraft is already established on the glide path and is looking at the aircraft altitude above terrain. So somewhere around 30 to 60 feet above terrain, starts aligning, starts commanding the flare, starts decrabbing, starts losing altitude, right? So now we are about 30 feet. Auto throttle is commanded towards the idle position. About 15 feet above the ground, it is commanded for the nose to start pulling up. And now we reach 4-degree angle on the nose, and we are going to be touching down at that point. So touchdown is detected by both weight on wheel switches, which are installed on your both main landing gears. And once touchdown has been confirmed by a small timer, basically less than a second on the ground, then we're going to start, the system starts center lining tracking. It's going to keep the wings level, and it commands a pitch down towards about a 1-degree position. So aircraft is on the ground, and now we have another function, or the AFCS, which is to deal with the centerline tracking. Basically, the system wants to maintain the aircraft somewhat centered on that runway so that we don't fall off of the runway. So it will rely on centerline position and orientation of the runway based on navigational databases. In order to steer, the AFCS uses the yaw servo, which this will have authority on both the rudder as we are landing at higher speed, and then the nose wheel steering through the nose landing gear steering mechanism as we start slowing down. And this is what's going to keep the aircraft centered in the runway. At the same time, the aircraft was going to start applying the brakes. Now, in order to be able to use the hydraulic braking automatically within the HomeSafe system, there has been some additions in order to add pressure to the hydraulic circuit from an actuator. So the architecture is similar to the one existing in previous TBM models, where we have the pilot and co-pilot stations through our pedals. And the system adds actually a third braking station. And this is what we see here at the top of that diagram. We have the reservoir going to another master cylinder, which is commanded by the HomeSafe system. So we see that we have a single master cylinder, which is the same as the pedal's master cylinders. And this is going to be controlled by a Garmin servo motor. It's a GSA 87 servo, which we use the same servo installation for auto throttle. So this is going to activate the master cylinder through a mechanical linkage, basically converting rotation to linear movement. There has been some modifications to the hydraulic rounding and also expanded hydraulic fluid tank to improve venting. So this location of this third braking system is going to be in the unpressurized part of the fuselage just behind the firewall in our avionics bay. Just a different view of the location of this new master cylinder equipped with the servo. And this is what we refer to as the third station or the third man in order to accomplish the braking action automatically. So the aircraft has landed and the system will apply the brakes during this emergency auto land. So once the ground is detected, the mode of deceleration in your AFCS is engaged and commands the movement towards this braking servo. The indication is to command it during the whole braking sequence at a maximum torque to generate constant braking. Now, being just a single station, we have controlled steering as well, and we are avoiding differential braking. So once the aircraft has stopped, the braking is also maintained, and it acts as a parking brake until HomeSafe is deactivated. So all of these things happen once the aircraft has landed. Now, there's an additional thing that happens as the aircraft touches down, and that deals with the shutting down of the engine. We're going to see that after this short movie here. I just want to show you an actual video footage of a HomeSafe landing, and this was filmed during certification of the TBM 940 a couple of years ago. You will see that in this video, the screens are not displayed normally. They are actually on HomeSafe mode. You might also see, as on the previous video, that there's an explanation why we have a red light on our landing gear control, and this is normal. This is due to, remember, HomeSafe bringing down the gears automatically. However, the lever is still in the up position. And you will also notice a little bit of muscle memory from the pilot as he tries to intervene an automatic landing, which I think is quite normal from every pilot. So in that video, we could see how the aircraft is set for landing, how the aircraft, it performs the flare before touchdown. And it was quite a smooth touchdown there. As it touches down, the aircraft automatically starts centerline tracking, maintaining that aircraft somewhat centered inside that runway, starts applying the brakes. And at the same time, and it's not noticeable, but the airplane will also start shutting down the engine. Now, there's not going to be any movement on our power lever here, but for the fuel management shutdown, basically how it does is cuts off the fuel supply. In this case, for the TBM 940, we have added an additional fuel shuttle valve, which has effect only on the right-hand tank fuel line. So the fuel shut-off function is performed by a combination of the shuttle valve and the selection of the right-hand tank on the fuel selection unit. This fuel cutoff is initiated immediately on touchdown. So just keep that in mind because, in order to shut down the engine, two things have to happen. Just before touchdown, at about 100 feet radar altitude, the system commands the selection of the right-hand tank. Once the airplane has touched down, the fuel shutoff becomes active, basically isolating the selected right-hand tank from the system, and now the airplane is going to starve out of fuel. This is how it's going to shut down. So basically, it's going to be a slow shutdown, which is going to be aided by the braking action and the lack of thrust from that engine. And that's why you can see the airplane that it rolled down the runway for just a little bit, probably longer than during a normal touchdown, during a normal landing. So this is the location of our fuel shutoff valve on the TBM 940. It is there on the right-hand side, just kind of like underneath your avionics bay panel. Now, we don't have this fuel shuttle valve on the TBM 960 because on the TBM 960, we have a FADEC system. So this is not necessary. And now the shutdown or the fuel cutoff is commanded through the FADEC. Emergency Autoland requires new software. And obviously, this function is a locked function inside our Garmin system. And for this, we will require an unlocking card that has to be loaded into the system. The unlocking process of Emergency Autoland is very similar to any other unlocking process in the Garmin suite, just like your electronic stability protection or your auto throttle. And then this will require loading of software from a loader card and unlocking of this function. As we said, this is available for all of our TBM 940s and all of the TBM 960 aircraft. We do have a new maintenance page introduced in the Garmin system, and this is used in order to perform regular checks on the system during scheduled maintenance. And when accessing this maintenance page, maintenance personnel can load specific modes in configuration, and they can test the system during maintenance. So we do have this specific maintenance mode, and it's normal that Emergency Autoland uses hard-coded logics in the GIAs to drive some of these outputs. So when we are in maintenance mode, we will be able to activate all of these logics from the display units. So basically, by pressing soft keys on the display units, we will be able to check, let's say, your gears coming down, your flaps coming down, things like that. And this was going to be done during our C inspection, where we have to check the HomeSafe system. The HomeSafe system will not be checked in flight. It is a maintenance action. And for this reason, we also have a CAS message when we are in configuration mode. So this, after we are done with maintenance, we want to make sure that we exit configuration mode completely. And if not, the CAS message is going to remain there. And what that does, it prevents flight because we are still on configuration mode. So it's something important to keep in mind to follow those instructions, how to exit config mode if the airplane is equipped with HomeSafe. So the whole idea here is if we ever have the need of landing the aircraft through a pilot incapacitation, the hopes is that it will be a safe landing and that this could save lives in the future. It gives peace of mind to the occupants, especially the non-pilot ones. And after the completion of a HomeSafe landing, there's going to be some important maintenance checks that will have to be done in order to assure the integrity of the aircraft. So if the airplane was to complete a home-safe landing, once the passengers have exit, basically displayed a few minutes after the final message, there's going to be instructions for the ground personnel and just basic instructions on how to shut the system down. Ideally, we will like all of their switches to match the position of the flight controls and the landing gears. That's why step 1 tells us to lower the landing gear lever towards the down position, also the flaps towards the landing position. And there's a recommendation to disengage the light data recorder circuit breaker, and finally to bring the crash lever down. By just turning the crash lever down, we would deactivate the system. However, just keep in mind that once the system is deactivated, the brakes are going to be released. So there's a possibility that the airplane might move if we have a steep incline on that runway. The HomeSafe system, throughout all of the indications for the passengers, it can play in different languages. And there has been several languages that have been chosen depending on where the aircraft is going to be delivered. So all of the instructions for HomeSafe, they could be played in English, in German, in Portuguese, in Spanish, or French, depending on where the aircraft will be delivered. And this can be changed in case of a change of ownership as well. So the idea here to disconnect or disengage the LDR circuit breaker is because we only have 2 hours of recorded audio on this. And if we don't disengage this breaker, well, we can have recording overridden when powering again the aircraft in the hangar. Remember that it's important to save audio recordings in case of an investigation. So that's why the recommendation for disengaging the breaker. Once the aircraft has completed a home-safe landing, our maintenance manual directs us to a full inspection before further flight. And this is an addition to our Chapter 5. Chapter 550 includes the list of maintenance checks that need to be performed after a home-safe post-landing. And there's going to be a lot of visual inspections, checking for fuel leaks. We're going to have to reconfigure the controls and the circuit breakers. One thing that is important is to extract the flight data and audio from the LDR and to be transmitted to the manufacturer for analysis. We're going to have to do landing gear checks, wing checks, basically a structural inspection on those wings. Remember that, things could go wrong, right? We also want to check our flight controls and fuselage. There is also a possibility that there could have been a prop strike. So we're going to include a little bit of a possible prop strike inspection and also power plant checks. If there is any damage found, additional checks will have to be performed. Once all of these checks have been done and we establish that the aircraft is safe to fly and to release after service, we can contact the manufacturer. And the idea here is to do a full data analysis from our fast box. And in order to, remember that there could be some particular conditions where a landing could have been performed through HomeSafe, and that could result, I don't know, maybe through an excessive drop rate, maybe something that has been deemed excessive, right? That could trigger additional checks as far as the structure. Also, we're going to look at the mismatch configurations due to the switches, which were override by the system during the sequence. And during this override, CAS messages are not displayed to the passengers. However, they are saved in the background. And us as the manufacturer, we can take a look at all of these CAS messages and do a more thorough investigation of whatever could have happened during that flight. For example, we can do analysis of exceedances, could be engine exceedances, could be airframe exceedances, things like that. And that way we do have a full maintenance release with all of the data that is available. This concludes the presentation for HomeSafe on the TBM 940 and TBM 960. Thank you for your attention, and it was a pleasure being with you today.